Okay. Right, welcome to apparently episode 13 of Coding a Little Interpreter in C++. Having a massive jumper because it's pretty cold here. Even though we had the hottest day recorded in February, I think ever, although often records start not back at day 0, but the temperature has dropped and it was jumper time. Didn't train today, I wasn't in the super energetic mood, so I just watched some Netflix with the children and then decided it was time to code. It's now, wow, 9:37, so in the evening, and well, it's not going to be a long coding session, I don't think. Right, anyway, without further ado, where were we? Well, I think we finished off. I just about convinced myself we'd got the calling convention for functions worked out, and we were able to return the value 100. So scrolls around. Let's get that bigger. Not quite that big though. We were able to return. We had this sort of program working, and off screen I went ahead and added multiply and minus and plus, and I'm about to add divide. So we can now do something like that. If we run that, we will see this is the return value. So this is the AST, this is the data bit. As you can see, what's interesting is in the data section we write the value 5 twice to look up. Eventually we might put smaller values into the actual instruction using the space we have there, but for now, variables, values get written out twice, which is obviously not efficient. But, go on, yawning already. 25 is the answer, so we've got a main function that gets called and it returns 25. Oops. As you can see, we are quite literally and pretty much I'm just searching for that. Oops. We do it like that. Let's return. So I stands for I32 inch division, and scroll down to here. Not the best way to do this. I say that a lot, but the sort of thing we will tidy up. But it's a case switch statement that converts our instruction to some text so we can see what's going on. And finally, and again you notice there's a lot of duplicate code going on here. Because we pushed them onto a stack, stacks naturally reverse things as you pop them off, so the right hand side is the first to come off and the left hand side is the second to come off. Hence we got the RHS before the LHS, and I decided to comment that. What's interesting here is I've got the naming wrong, which I knew I had. It doesn't matter because plus operator commutes, so it doesn't matter the order of you do them. In fact, it's only minus and divide where it matters. Consistency is important. Now hopefully that will return 1, but we shall see. It returns 1. Awesome. So if we put 10 there, it should return 0 because we're doing inch division. If we put 500 there, it should return 50. Yep. I'm good with that. And we've done all the multiplies. What have we got next? I also added true and false. Some argue you should do -1, because then when it's unsigned, you can and it, you always get true back. But I did notice that stood ball in C is defined as 1, so I went with that for now. Excuse me. Oh, what jumping around going on the screen there. Unary minus and unary plus. Let's do that then. Now I could make an instruction. Unary minus, or I could use my push to multiply by -1. So what we could do, instead of making an instruction, we can multiply that, and then we can do finally multiply by that. Unary plus is like a no-op really, so we just fall through it. Well, it's fine. So unary minus, we take the number, push that on the stack, we push -1 on the stack, and then we multiply. So this should give us -10. This should give us +10. Yes. Nice bit of synthesis of instructions. Some we're not doing yet, we've got a lot of work to do there. Equals. So part of me, many assembly languages have a compare function which sets a register with the result, so it sets it with less than, greater than, equal, and so on. I'm at the moment going to go with having an instruction for each comparison type, so I equals, and then we're going to push the result of those two onto the stack as true or false, or in our case 0 or 1. That way I'm trying to keep it as stack based as possible. So yeah, got 2, we know got 2, let's put a 2 in there to make that one pop out. And then we have I greater than, I less than, and so on. And then when we have floats or I64s, we'll have more instructions, but just the way it goes. to keep it right. And now I want 1 and 0, and I want to ensure we've got 1 and 0, so we're going to use the ternary operator to make sure we do. Now, because we're going to be looking at balls, we need, well, let's test it. 10 equals 9. That should fail. Type mismatch in return, yeah. Because we need this to be a ball. And yes. I really don't like that. First of all, we don't need that there. That there. And we don't need that there. If actually what it is, can I turn that? Look at all those. Okay. I think it's important to keep that the way it is. Well, we really should certainly when we get to some sort of pattern matching switch style thing in a little language, we shall not have automatic fall through. Greater than. Just running through all possible combinations. Yep, appears to be working. That's greater than done. Now those are redundant because it's now very obvious. This. That. Result of X is 100. Oh, now during. Good. Just again running through the combinations of things to make sure we've got it working. False. 100. Yes, I could write some unit tests, I know. Actually, we should be doing that soon, I would imagine. That, as far as I know, is all we have left, I reckon. So I think, where are we? This is the switch. This is the execute. Okay, so we should only have left the variable lookup, which I'm trying to find. I'm inventing a structure, so I need to be looking at compile time. Right, print this guy. Oh, variable definition, variable lookup. And assign. That is they all require me to annotate the symbol table and to flatten things out a little bit. Sorry, a whole load of context in my head that isn't explained. When a function's called, we're going to, on the stack, allocate enough space for all the local variables inside all the code blocks in that function. So anything created in an if statement code block or an else statement code block will all have its space on the stack allocated when the function's called. So we won't move the stack frame whenever we enter a code block and then reduce it. It's all going to be done at when the function's called. From that, we have to then effectively assign every single variable an integer ID, so we can move from the frame pointer upward, or I want to say downwards because that's how hardware stacks work, offset from the stack frame pointer to the local variable that we want to do. All that requires us to go into the symbol tables and basically say, hey, what's your identifier? Not in the mood for writing that tonight, so quite a long day, and good day. Went to the beach and had a fire and made some coffee and a few other cool things like that, but I'm not in the mood for attacking anything too complicated. So let's merge this in. What time is it now? Just gone 10 o'clock. Let's commit it. We still have quite a few things. In fact, we've got a few funny goings on, conversions going on that we shouldn't have. Let's reframe on that. What I would like to do is a little bit of tidy up. We've got this VM. But we don't really need the VM to be exposed, do we? So if we here we go. Now, if I just size T that, and then what I'm trying to do is eliminate the need for the VM for the most part. Okay, I'm going to assume that's good. Awesome. And then we're having a class if we're not making much use of it. Instruction pointer. I'll probably find myself this lovely indenting will not survive the first call to that. Oh, it did. Cool. So now I have to For now, the VM just consists of a stack. We don't want a VM like that, do we? Oh, what am I doing a void there for? What we want is this. I don't like that. Virtual machine stack. That's good, isn't it? Maybe we want put you. Started messing around with C with a little bit of OpenGL stuff, and in C I tend to do, I would have done VM stack underscore T, whereas here I'm using the capital letter. Why I'm flipping on those, I don't know. It doesn't make sense to keep changing. Now, what we have is this becomes a push I32 stack. Cool. Why are you not like? Because I initialize you there. No matching call for push. I32 stack. No, I want you to be a you want to keep these separate. Separate to the pushing and popping, so they are just returning that. If I just comment you out, I will get told where you all are. is mind-numbingly boring. I'm really sorry for streaming this. Well, there's a little bit of... No, it is mind-numbingly boring. As you can tell, because I've gone quiet. I suppose I could think of something to say. I'm not really sure what to do to say though. I could just talk randomly. I did notice that C++ C++20 recently got a bit of a kick because a meeting happened, I think, in Hawaii, and a few decisions were made. Modules are coming. I've not done a deep dive on those. Some people, you get people ranting both ways, so I shall be taking a look at them at some point, but I'm probably going to leave it until 2020 at least. Mostly because I'm happy to let there be a bit of fallout on that. Coroutines were also added, which is great. I didn't think they were going to make it. That's something I haven't looked at them properly, but coroutines theoretically, well, I think they originally were done to make parsing a lot easier, and you can rewrite a parser and tokenizer using coroutines and avoid all the recursion that goes on, reducing your chance of stack overflow. I believe the Zig compiler in their rewrite Zig in Zig version has made use of those for the parser. I've never written one using a coroutine style, but I should look forward to doing so. I did at one point actually consider using Zig to write the interpreter, but again I figured that I would spend more time learning the language. My goal of this project is to not learn a new language, but to kind of create a little one. Trying to know what else is coming in C++20. There's a lot. I think there's some lerping functionality and things like that. No reflection, which would be great. And named designator initializers, which is a feature straight out of C, except with a few more limitations, but it lets you do something like, if you've got a pointer class, so vector2, so vec2 you can do .x equals 100, .y equals 50. Importantly, if that's a vector 3, if you miss the Z component, it is default initialized, so in C that would be set to 0. In C++, it would use whatever I have no idea what this type of construction is called, I can't remember. Inline constructor initialization, inline initialization, class-based initialization, who knows? This type of initialization happens. So in this case, pos would equal an x of 100, a y of 50, and a z of 10. They have to be in order. In C, I think it's valid to write something like that, but in C++, that will be a compiler error, I believe, or at least warning, in the same way that if you get the initialization on the constructor initialization list thing, construction variable list initialization thing, I'm sorry, I can't remember the name of that either, it complains at you, saying you've got the order wrong, this could be terrible. I'm sure it could be terrible. I've never really hit many places where it would be. It all depends on whether it's something coming after it. It should be an issue. It has to be, relies on something before it. Seems a weird restriction, to be honest. That if they took it out, I'd probably complain. So, C++ 20 looks like it will be, adding some reasonable things. I'm always wary of the libraries more than the language changes. I usually like the language changes. The library stuff I learned to be a little bit more careful. Ranges is coming, I suppose, in C++ 20, and I believe concepts are as well. So there's a lot of changes, and obviously going to be a reasonable amount of learning, but some of them come with a huge cost. I believe the ranges stuff is going to be quite slow to build, so while I may like it, I may not use it much. The same with concepts, which are, as I understand it, constraints on templates, but from what I could see, it looked like they were going to be a little bit heavyweight. I could be wrong. I watched a talk with someone last year, and he was doing a live demo of some of their concept stuff, and in just a few little additions to limit the types that could go into a template class he had, you could see his computer struggling. Now, fair enough, it was a live demo, it was, and hopefully the compiler writers would have improved that. But if not, I can see myself avoiding that as well at home. I have a much lower tolerance for waiting at home. At work, I tend to use a lot more, the STL, and that's, the way they build software. So if we reboot this project, let's see how long it takes. 882 milliseconds, along with a couple of, let's fix that warning. What are we complaining about? Oh yeah. We don't want a string ID, although we hope we will be able to soon. There we go. No, that won't. So let's rebuild the project. This is obviously in debug. 0.8 of a second. Now, that seems cool, but it's not very quick. So, if we do a C-log on the source, we're probably at 1500 lines, 1600 lines. So, in debug, we're taking 0.8 seconds to build 1700 lines of our custom code. Now, obviously, custom code I've written, obviously it's actually building a hell of a lot more, because I include stuff like standard lit, standard IO, vector, all those things, and every single vector instance creates a whole load of more stuff the compiler has to deal with. But 0.8 seconds is a long time. That's an awful lot of frames per second of a game. If you go and play Battlefield 5, it's doing 60 frames a second, roughly, or more, maybe less, but the 0.8 would be 4/5 of 60. 1/5 of 60 is 12, so 4/5 is 48. So it's doing 48 frames. Which is in a time it takes my compiler to build 1700 lines of code. I'm not going to rant. Promised myself I wouldn't rant on these things. I'm going to review once a month. Right. Where are we now? I'm meandering because I don't want to. Ooh, last sibling. Let's take you out. Cool. Enter child, enter parameter. Guess he didn't worry too much about that. Level used. That's not very happy about that. Claimed ID. Expression is redundant. Is redundant expression. I wonder why it thinks that. Who knows? Well, 42 to do items. All in our source directory. See if there's anything in there we want to tackle. That's a bigger thing. Oh god. Should I do an error code? Honestly, I mean, why have we not just switch on that? Because we don't know it at one time. I'd have to convince myself we actually needed to do that first. Should be needed. Should not be needed, I suspect I meant to say. And let's just go into here. Using new instead to do this, is this even used? Probably not. To do store the signature function. I believe we do that now. In the old symbol table. I believe we don't do that now. So how the hell are we? Well, probably not because we haven't checked it. Take that out. This will be causing many allocations. It will be causing many allocations over here. To do move to the symbol. Let's do that one. Too many bit of work. We take longer to move this down. Do it exist? Does it exist? Goes. It's all built. You put a little sad face there to do hard enough. Don't decon fail. Yep. Although I don't want to leak memory obviously, but memory leaks in a compiler are not the worst thing on the planet. Memory leaks in server software are terrible. Memory leaks on normal desktop software is terrible. Memory leaks on a program that you run and it exits, or hopefully within the space of a few seconds, the OS will clean up all the memory and you're back to in good state. So, you know, it doesn't leak. If it leaks, it gets cleaned up within a few seconds. So it's, you know, not the worst thing on the world. I believe the D compiler, not the one using LLVM, but the original one, was optimized so that it was fast, really fast in generating a debug build. And the two optimizations that the guy, whose name I can't remember, he gave an interview talk on some website, said that the two optimizations he put in were, he optimized the GBs, can you say that word, out of his hash table, his custom hash table, so that it was super quick on when he had only 8 or 9 entries in it, because the code they saw mostly had 8 or 9 entries, 8 to 9 variable, up to 8 or 10 local variables in each function. Therefore, the hash table was used as inside the symbol table, a bit like we're using, well, we're kind of using a vector, but we will move to a hash table. So you wanted really fast to look up on the general case, even if it meant that someone had created a function or method with 500 variables, it wouldn't be as quick as it could be. And the other thing he did is he never deallocated memory. He just kept on adding it, and then once he finished compiling, half a second later the OS would clean it all up for him. So, you know, his view was, why worry about it? Obviously that's not a view you can hold on all programs you write, and not one I hold super strongly. I think if you get your allocations down to a few big chunks, or use Arena allocators, you know, you can optimize this stuff to being fairly, not taking up too much time. Obviously you use the traditional OO way in C++, where you allocate every single object and assign it a unique pointer, and you're going to run into a few problems, which is actually what we've kind of ad hocly built with our vector of pointers, which are basically a register to what allocations we have, and then we delete them at the end. Inside, I'm talking about inside the parser now, I believe. Here it is. This is where the allocations are registered, which lets us only deal with raw pointers in here, and then we just delete them. So it's a separation. We could have used the unique pointer here, but that would mean that the AST node then had a destructor, and it would have to walk every single AST node, deleting first child, which would then call another destructor, which would then delete first child and sibling, and so on down. So if you're parsing 200,000 lines of code and you're generating 5 AST nodes per line, doesn't seem that unreasonable. 200,000 lines, because you've got 1 million allocations in theory. And when you deallocate, you walk that whole tree, drill all into memory, walking down, and all you're really doing is just deleting other AST nodes. So what we've done here, which is just as bad, is we store them in a vector, so we're potentially getting extra allocations when we're allocating as the vector resizes, and then we walk over all the vectors, deleting them. There is no destructor in here. In fact, if we do AST we can't because it's not letting us do that. Soon we will be able to write that. Let's put, no, we can't do that. So when we have so what we've done is instead of hooking in the memory management into the AST node, we said, okay, we're going to pretend that someone else is handling the memory for us and we don't have to worry, so we can use 4 pointers. This separation of concerns means that we can get clever with this allocation, and at the moment it's a dumb way, no doubt about it. But we should be able to use a memory arena, which perhaps will allocate or AST pool, where we might allocate 50, 100, 1,000 AST nodes in one big chunk of memory, and then gradually feed them out as and when it's needed. And then when that's used up, we just allocate another, which we'd still have a vector of allocation somewhere, or some equivalent container to store them. But we could allocate it per megabyte, so we could have thousands in there all at once, and then we just have to walk over a few megabytes, a few pointers, deleting a megabyte as we go, so drastically reducing the number of deletes. Deletes can be slow because it has to do all sorts of weird, memory allocators are pretty complicated. Worst case, it's having to do putting the nodes into a linked list and then figuring out how to merge if there's if we've allocated 2 AST nodes and they're sequentially in memory, when we delete them, the memory allocator will want to merge them back together to perhaps the small memory allocator tries to merge nodes back together, small object allocator inside a memory allocator tries to merge nodes back together to create larger and larger chunks of memory, mostly to avoid memory fragmentation. So there's a lot of work going on in there under the hood, and we want to avoid that. So that's the strategy. This separation will eventually give us the ability to use different forms of allocations. Whereas if we'd made these two guys unique pointers, we would be stuck with per object allocation. Every single time we'd be hitting the standard allocator. There's other ways you could use. End result is that if we make a lot of things without ST nodes, we can also have a single allocator that could allocate strings and all sorts and not actually track the type of what it's got. Child pointers, not strings. And not worry about having to run a destructor on them, so it doesn't need to. It's just thinking about memory, so it's not at all worried about being able to run a destructor. So it doesn't need to know the type of the memory or the type of the thing allocated into the memory. Therefore, simplification. Ran talk over, probably not making much sense. And how are we doing? We've been going for an hour, so. I think, because I'm not super motivated, I might call that a day. We've tidied up some stuff, we've added in the more bytecodes. All we have left to do are the variables. I might have a little look at them and see what I can find. Off screen, but I'm also tempted not to be honest. When it's sort of mode. What's this guy saying? Typo in Word. Oh, well. And, yep, I think that's as good as it gets tonight, I'm afraid. Okay, right, okay, thanks for, well, there's no one watching at the moment, so thanks for not watching. And I shall, tomorrow, not quite sure when I'll get to stream next. And God, I love you. Roll on the summer, get out in the sun, do some beach stuff. Yeah, okay. Sorry, I just looked at OBS and I noticed that I was not looking healthy. Although I'd had quite a few colds this winter, so maybe it's time to get healthy. Right, where was I? I'm going to stop streaming before I start boring you with my life. Okay, right, thanks a lot. Until next time.